Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones.
Hi, I've had a lot of people ask how I got my start in electronics, and it's a really interesting question. So I thought I'd go back in time a bit. I got my flux capacitor t-shirt. Let's go back in time and see how I started and see what electronics was like back in the old days. There's nothing unusual about how I got into electronics. In fact, I think it's very typical and the common way almost everyone got into electronics back in my day. How it started for me, I was probably 6 or 7 or something like that, and I kept taking things apart. Everything in the house, this is the late 70s, mind you, in the house I'd just be taking everything apart. And my parents got sick of it. They hated it. So what they did is they went out and they bought me one of these. And this was magic for kids in my day. What it is the Tandy/RadioShack Science Fair kit. This is the 200-in-1, but my parents first bought me the 50-in-1, which I think was the original one which came out. And this is what got me and a whole generation of electronics kids started. Back in the 70s or early 80s and or before that, of course, if you had an interest in technical stuff, taking things apart, wondering how things worked, then getting into hobby electronics was a natural progression. It was really the only sort of progression you could go through. There were no distractions like there are these days with computers and the internet and games and everything else. Well, you got to remember, computers were around back then, the very early home computers, but really only, they were quite expensive and really only well-off families could afford them, and really they were pretty much toys and you hacked around with them, and you know, you had to be very technical to sort of use them. So one of these RadioShack Science Fair kits was pretty much, one of the few things on the market that let you, a kid, easily experiment with electronics. And they're fantastic. If you haven't seen them before, they got all various components on there. There's resistors, capacitors, relays. There's a couple of 7.4 series TTL chips on the front. They've got controls, LEDs, switches, a CDS photo cell, a lamp, a speaker, a meter, a tuning cap, a volume control, and they've got transformers on there, and they've got all the components hooked up with these spring terminals. And what you did is, it's easy. They came with a whole bunch of these wires, and you simply stuck them in to the terminals, and you could build, as the name says, this is the 200-in-1, you could build 200 different projects. Wow, this was fantastic. For a kid, this provided years of enjoyment. So as I said, I started out with the 50-in-1 and I outgrew that, and then the parents bought me the 150-in-1. They were in the wooden boxes, as a lot of people will remember, I'm sure. And then I outgrew that one, so they got me the 200-in-1. And I've still got the 200-in-1 manual for it. And if I check the actual date, it's copyright 1981. So there you go, that puts me at about 9 years old. I got this when it first came out. I mean, check it out, look at it. What kid is not gonna salivate when they see this? Maybe not today, with all the gadgets all the kids have, God. But back in the 70s and 80s, this was just awesome. And you got this great manual. And look on the front, there's a cool little character dude. And if you read it, it says, "Come with me to the world of NOR gates, flip-flops, transistors and LEDs." Whoa, fantastic. It was a whole adventure. And then you open it up and check it out. There's 200, no less than 200 different projects you can build. Fantastic. Digital rhythms, sound machines, electronic metronomes, electronic roulette with sound, the light fantastic, ESP tester. What else have we got? Voltmeters, octave generators, winking LEDs, the phony counter. God, fantastic. Sound scooper, discharge timer, the quick capacitor. Oh, man, this was a gold mine when I was a kid. Fantastic. Now, the good thing about these Tandy kits is they started out, the first 20 or so projects, giving you a picture of the board and a wiring diagram of how to actually wire it up. And then they would progress to, ta-da, schematic diagrams. So they'd take you gently from just, wiring up the things through to schematic diagrams, and then there'd be text for each project explaining how it worked, and then they'd get progressively more complex as you went along. Roulette with sound and stuff like that. And it was fantastic. It was a real great way to learn, and I think you can actually still buy similar kits today. But I don't know if many people do, but it's still I think the best way to get into electronics. Then what else did you do? Well, when you're a kid, you saved up your money and you didn't buy an iPhone or something like that. No, you went out and bought a damn multimeter. RadioShack, this is a 20 k ohms per volt analog meter, and it's the first meter I ever bought. I think I was about 8 when I got this, and I saved up my pocket money. I went to Tandy and I was so proud. It took all my pocket money. I bought a multimeter. I still have it and it still works. Beauty. So, what did you do after you finished playing with your Tandy 200-in-1 kit and you had your multimeter? Well, what you did is you went out and you bought a breadboard, you bought a whole bunch of parts in a big grab bag or something like that, and then you went to the newsagents and you bought magazines, electronics magazines. In my case, because I'm from Australia, the magazines of the day were Electronics Australia, Electronics Today International, Talking Electronics, and there was Australian Electronics Monthly at some stage. I'm not sure of the progression anymore, but the magazines were the holy grail of hobby electronics. It's what the whole industry was based around, and if you didn't have these, you weren't in the hobby electronics business, really. And then you went to places like RadioShack and you got stuff like the Forrest Mims Engineers Notebook. I'm pretty sure this is Forrest Mims, if memory serves me correctly. And you got stuff like Getting into Microprocessors and the Introduction to Digital Electronics and stuff like that. And these you could buy at your newsagents or at RadioShack, and they were fantastic. And, well, not much has changed these days apart from the information revolution, which I'll get into. The only way at the time to get information in for electronics was in these books and magazines I've shown you, and the other place were these Databooks. Every electronics hobbyist worth their salt had bookshelves, and I'm talking complete bookshelves full of Databooks. This is all that remains of my extensive Databook collection. I had at least two or three full 6-foot-high bookshelves filled with these Databooks. And you had things like the TTL Logic Databook, thousands of pages. And you had stuff like the Linear Applications Databook, operational amplifiers, CMOS logic, all that sort of thing. And really, the only way you could do electronics, the only knowledge you had of what parts to use and circuits and things like that were in the magazines you had in your personal library, the magazines and the Databooks. You couldn't get information any other way. It was either up here or it was in your personal library. Who the hell has a personal library anymore? You don't. It's called Google. Now you got to remember, kiddies, there was a day before the internet, before cell phones, before credit cards, before online shopping and all that sort of garbage, which you just take for granted these days. But back in the old days, when I was a boy, there you go, you had to, what was in your personal library was all that mattered, your own personal components collection. Online component suppliers wouldn't sell you 100, 200,000 different components like they do these days. No, they were lucky, they sold the basic range of chips and you had to build everything around those chips. Microprocessors weren't really, microcontrollers, PIC and Atmel and all that weren't really around back then. Oh, they were, but they didn't have all the built-in features and everything like that, and they were very expensive and difficult to develop for and everything else. You had to be a business to get into, an 8051 microcontroller back in, 1980 or something like that. And how were your building projects? back in the old days, well, if you weren't building it on breadboard or using the point-to-point method, you were using some Vero board, which you can still get these days. A lot of people still use Vero board and breadboards. They're still common, so they've survived a long time. Or you made your own PCBs, and you made them using either tapes like Bishop Graphics. You would actually get a clear film. Here's some photos. You actually get clear film, and you would get these all the different pad shapes, and you would stick them down on the clear film, and then you would route the tracks by hand using Bishop Graphics or something else. Or you used a Dello, what was called a Dello pen. I think it was a trademark name back then, but it was basically a special felt texture. You drew your circuits directly onto the copper board. There were no computers with CAD software back then. They didn't come around until the late 80s, really, affordable ones. And, so you built your own, you laid out your own boards, and you hand built them, because you couldn't. If you wanted a PCB professionally manufactured, it's not cheap like it is these days and plentifully available on the internet. No, you order it from China direct. No, back then it was very, very expensive to get a PCB manufactured. A hobbyist wouldn't even think of it. And things have certainly changed. I mean, back in the day, you didn't have circuit simulators. They didn't come around until the late 80s as well. Test equipment was really expensive, so you built your own. You built all your own test gear. You built your own power supplies, your own function generators, your own logic probes. Some people even built their own multimeters and all sorts of things. And you would salvage old parts. People used to build their own oscilloscopes. And I can remember my first oscilloscope. I'm not sure of my exact age, probably 13 or 14 maybe. I can remember I saved up $800, I think it was, thereabouts, and I went to David Reed Electronics in Sydney, and I bought a brand new, I was so proud, brand new 20 megahertz dual channel Kikasui, which was a top brand oscilloscope, analog oscilloscope back then. And yeah, I had that for many years, and that was my primary oscilloscope. That was my first one. So I didn't get one for quite a while, because the family wasn't rich, and I had to save up my own money doing odd jobs and things to pay for it. So those were the days. Now, heck, even kids have credit cards. They just, $1,000 oscilloscope, that's nothing. The hobby magazine was everything back then, and I thought the people who wrote for these things were gods, and but I thought I could get something published in here one day. And I think I was 12 or 13 at the time, and I submitted a circuit into Electronics Today International, I think it was my first one, and I couldn't believe it when they published it. I was speechless. And to this day, I still get a bit of a kick out of getting a design published in an electronics magazine. It's maybe I'm old-fashioned, but there's just something about it which just makes you feel proud, really. I can remember too, back when I was young, I had no support whatsoever. Yeah, the parents bought me the kits, but they just left me alone. They didn't know anything about electronics. I didn't know anyone who was into electronics. All my friends weren't into it. So, I was pretty much on my own. And even at school, they didn't teach electronics at school, even in science classes. Yeah, they taught you basic electricity, but, that was pretty much it. And I can remember one of the magazines ran a schools competition. It was specifically for kids in schools. You design a project, and the best project won an oscilloscope. And I was probably 11 or 12 at the time. I was in high school, very early high school, and I can remember that going to the teachers and showing them the thing and, look, can I enter this? Because you had to have your school, sponsor you or support you. And they just went, what's that? That's garbage. No, go away. We don't want to know anything about it. And I was so disappointed. And you wouldn't believe it, I can remember the guy who actually won that contest, because I was so jealous. I thought my project would have beat him. And wouldn't you know, probably about 1993, about 10 years later, I actually ran into him at a job. And I was working at, I think, KeyCorp at the time, and he turned up, and there he was. I remembered his name back from the very early days, him winning that contest. He couldn't believe that someone actually remembered him. It's a small industry. Now, while I was mucking around with these Tandy kits and my breadboard and my multimeter and even my oscilloscope and things like that, I didn't really know electronics. I was mucking around with it. I sort of, I knew Ohm's law and a couple of other things and just enough to get me through and to allow me to, put building blocks together and build circuits up and have them work and troubleshoot them. But I didn't really know the intricacies of it. But I thought that gave me the absolute best background possible. So when I started formally learning electronics, I started real early. I started at the age of 15, believe it or not, is when I actually started formal engineering education. But that's a whole other story, how I started that young. But when I started learning, I found that things just started instantly falling into place for me. Well, I noticed everyone else in the class was struggling trying to learn all this stuff and comprehend it because I had this 10 years or 7 or 8 years worth of just tinkering and knowledge up here that things just fell into place at an exponential rate and I learned, boom, I just took off. And really that's how most of the best broad knowledge guys in the industry today, that's where they got their background. It's not through formal university or some other education, that just produces people who don't really know much. The best people in the industry I've found by far are the ones who started with a hobby background like me. Even if you didn't know what you were doing, it helps a lot. So is electronics different these days? Well, yes and no. No, in that, well, people still build stuff on breadboards and Vero boards and they still make their own PCBs and there's still electronics magazines around and people get published in them and stuff like that. But what's changed, the major difference is the communications revolution. And I'm talking about the internet. That absolutely changed everything. I'm talking probably mid-90s, 1995 onwards is when it really took off. Because that's when there were very specific advances in terms of PDF, the document format which we now all take for granted. That was the death of the humble data book. When you had to have this huge collection of data books and literally overnight that completely died. I gave away all my data books in mid to late 90s because everything was becoming available on the internet at the touch of a mouse button. It was amazing, and that made all the difference. And online commerce as well. That's the other big thing. Now we take it for granted. You can just buy something from any country in the world on the internet with your credit card or PayPal, and it's just so easy. Piece of cake. But no, back pre 1990, the mid 90s, you had to make long distance phone calls. Oh, really expensive. Can you believe it? And if you're at work, your phone desk wouldn't even have your desk phone wouldn't even have long distance capability because they didn't trust you. It was so expensive. So you had to go through local dealers, and it would take months, and lead times were huge. Yes, the lead time for that chip is 40 weeks, sir. But now there's DigiKey and there's Mouser and there's Farnells, and they've got hundreds of thousands of parts available, and anyone can build anything they desire with very little money. One engineer now can, within months can produce a world-leading product. But, back in the old days, that was much, much harder because you were limited to what you had up here, what you had in your extensive library, and so forth. And it was so hard to get parts, especially in countries like Australia. It was probably different in the US. If you were living in Silicon Valley, it was probably real easy to get stuff. But hey, not in places like Australia. So is hobby electronics dead? Is it dying? Is it in its death throes? The last nail in the coffin? Well, not really. A couple of 5 years ago, I probably would have said, yeah, it's pretty much going to die. But then it made a bit of a comeback, and it's making a huge comeback now due to things like Make magazine and these what they call hackers, and makers. Hackers not in the software hacker term sense, but in hardware hackers. These smart kids now, they've got all their iPhones and their smart gadgets. There are millions of gadgets they've got these days. And the ones who are curious about how they work, what they do now is they hack them. And, well, that's in the spirit of the old-fashioned hobby electronics. It's essentially the same thing, just on much more high-tech hardware. Heck, there's people doing reflow soldering of 1,000-pin BGAs on frying pans in their kitchen. You gotta be kidding me. But the people these days have no fear of doing something like that. It's unbelievable. Man, guys like me with all this knowledge, we're too scared to attempt something like that because we know the pitfalls, but not these young fearless kids, these young hackers. It's fantastic. Keep it up. So, would I prefer the good old days of Databooks and pre-internet when things were much simpler? No bloody way! Give me the communications revolution. We were so crippled back then in our capabilities, and we didn't even realise it. But with hindsight, it's obvious that we were. There was a limit to how much you could do, really. It was just so difficult to do stuff. Nowadays, one person, one hobbyist, one hacker, one maker can change the world.